Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Now, if you're new to the show, my name is Shawn Tierney from Insights, and I want to thank you and our entire audience for tuning back in this week. Now, in this episode, I sit down with Soroush from Novarc to learn all about their AI-powered autonomous welding robots. Guys, this is very interesting stuff. So even if you're not working on some welding robots right now, I think you're going to find this extremely interesting. And Soroush is a controls engineer, so he can talk our language with us. So I think you guys will find that very interesting. Now, before we get to that, we do have one announcement, and that is to thank Novarc for sponsoring this episode and underwriting some of our production costs. In appreciation for the sponsorship, we release this episode on all platforms ad-free, and we also include helpful links from the vendor in the description in case you want to learn more after you listen to the episode. So again, I want to thank Novarc for sponsoring this episode so we could release it to you ad-free. Now, with that said, let's go ahead and jump into this week's episode and learn all about AI-powered autonomous welding robotics. Soroush, welcome to the Automation Podcast. I'm excited to have you on the show to learn about what your company is doing. It was some pretty exciting stuff with robotics. But before we get into that, can you please first introduce yourself to our audience?
Well, first off, thanks so much for having me, Shawn. My name is Soroush Karimzadeh. I'm the CEO and co-founder of Novarc Technologies.
That's awesome. Can you tell us a little bit about your company?
Absolutely. Well, first of all, a little bit about my background. Actually, I'm a fellow control engineer from my education. So did my bachelor's and master's actually in industrial automation specifically. So very much passionate about what control engineering does for this world. About the company, we started in 2014 with the vision of bringing the new forms of automated welding solutions to the world. Our first try at it was our spool welding robot, which was the world's first welding cobot, launched in 2017 in Chicago. And since then, we've been on this journey of crafting and creating these new welding automated solutions that did not exist before, allowing people to engage with these systems and achieve those productivity numbers you're looking for, improvements in weld quality.
Yeah, and thinking about a welding cobot, that's pretty innovative. A lot of the welding systems I've seen, they're very big, they're very structured. You have to get the part in front of them. And so a welding cobot sounds like pretty innovative. And so tell us a little bit more about what you're doing now here in 2025 and 2026.
So we have been expanding the capabilities of this cobot beyond its initial, say, GMAW or MIG welding capabilities. Over the last few years, we added TIG and also TIG-MIG version of it that we have launched. So that's been on its journey of growth. We over the years, we also added additional AI-based autonomy capabilities to it, so which we call Nova Autonomy. With Nova Autonomy as a software that runs on top of spool welding robot, it allows the robot to become autonomous during the weld process itself. And what that means is that if there's variations in the weld process or the part, the robot can react to them in real time by just seeing and reacting, just like human welders do. When you're welding something, I don't know if you've tried it, but you'd be holding the torch, you're going from point A to B, but if you encounter any issues, if you have to course correct or you have to change weld parameters, you can do that with your hands and using the welding torch gun. Similarly, this robot cannot do that using AI in real time. And that's kind of the genesis of what we've been working on in the last 2 years. Back to your question, 2025, 2026, we've been very much focused on how do we enable the operational stock of welding robots, which is second or third largest population of any robot actually in the world, believe it or not, and partly because of the fact that this is one of the most difficult things that needed to be automated. So as early as 1960s, people started applying industrial robots for welding applications, being one of the dull, dirty, and dangerous things. So that's why it kind of has peaked in terms of its adoption of robots in the application. But the problem with these robots is that they don't have a way to see and react in real time to different weld scenarios. And that shows itself in how this automation is being used today. People have to overweld, which means they just put more material to join the two sides, or they have to grind it post the weld, which is a very tedious job in itself, or it shows itself in rework. Parts need to be redone. And aesthetics of the weld, which is also a very important part of what our customers care about. So what we can do with these robots is, as I said, there's 400,000 of them in the world today. and giving them that power of perception so they can see and they can react in real time. And the brains, of course, so they can react in real time is a key productivity enabler for our customers who are looking to get more out of their investments.
Yeah, so we can think of a production line if you're making a lot of products, right? And a lot of the stuff we have in industry is welded, okay? So if we're making these products and we're over welding, where that's money, right? We're just using
Yeah,
a lot
absolutely.
more money and energy. If we're putting down a bigger weld, it's more energy too. If we're having to grind, well, that's kind of like the last thing you want to do is rework, right? Sometimes
Absolutely.
it's not avoidable, but you definitely don't want to rework stuff, right? The less rework, the better. And I can see like what are some of the things. So, in a perfect lab environment, the weld would be great every time. But what happens on the shop floor that causes these type of issues to crop up before we apply your new solution? Like what would happen with just a standard, automated robot that would cause it to either need rework or grinding or other things to be done after the fact?
You nailed it, Shawn. So yes, in a lab environment, you can create a perfect weld, but that almost never exists in reality. In a production floor of a manufacturing facility, the incoming parts from the suppliers have variations. It could be just the steel and how it was formed. So there's thickness differences, for example. Once the steel rolls in, whether as a pipe or as a plate, it needs to be prepped for the welding. So you have to basically form it to the part that you need to manufacture. And that in itself requires, of course, bending or cutting or beveling it. All those processes have tolerances, and usually they're done manually, actually. The latest, just before the welding stage, there's a station called fitting stage where the parts have to come together. They're fitted together
Yeah.
by manual welders, and they put a tack in to hold the pieces together as it rolls into the welding station. That process again is a manual process. So if you add up all the variations in the upstream process from the raw materials differences, thicknesses, diameter changes, all those tolerances means when you start welding it by a robot or by a human, doesn't matter in that case, it's just a lot of variations that whoever is welding it has to deal with. And it still has to make sure the weld meets the quality standards that are required for the service of the part or pipe, which could be quite high, actually. Like, for example, if you're welding something, it has to meet the ASME Section 9 weld quality requirements. Then these are pipes, for example, that go into, say, high pressures for gases, or in other examples, when it goes to very low temperatures, say in the oil sands of Alberta, or you have sour gas service. That means the weld has to be perfect. It has to be very low repair rates, say less than 1%. So on one side, you have this high variation coming in. On the other side, you have to have almost surgical welds that have to go out with a very low repair rate. So naturally, I mean, humans are really good at that, right? We can see and we can deal with those variations as they come up. I mean, a trained welder, I'm talking,
Oh yeah.
can do that. But for an industrial robot to be able to accommodate, and the control engineers who are designing these systems, I mean, this is one of the holy grails in welding automation. One of the biggest unresolved issues in welding has been the fact that you had to either control the upstream processes to make sure there's almost no variations, which is impossible, or you had to, try to write in basically different weld schedules that would be called upon in different scenarios, but that would all have very limited effectiveness in solving the problem. And now, for the first time, by really leveraging the latest in AI and vision systems, we can, and the compute power that we can deploy to these cells,
Yeah.
we can actually solve the problem effectively.
So, in classic automation, when you're building small parts, a lot of times you'll have a vision system or sensors there, and the parts you're making lots of parts. So, like bottles coming off the soda line, you're looking for the cap, you're looking for the level. Very easy to see with common off-the-shelf sensors, and you just divert anything that's not perfect. When you're making parts, a lot of times they'll go through a quick test. So small electronic components like the buttons on your door in your car, they have a test stand. They go through, and maybe all of them or just some of them go through and get piece tested, and that's very easy to do. But when you have larger systems that are being welded, I mean, a lot of times the human eye is not going to be able to see some of unless you've been doing this a lot. If you're substituting for somebody on the line, you may not be able to tell that there's a slight variation in the raw stock that you're putting into the jig that you're tack welding together for the machine to do the final weld on. And so if the robot itself, the welder, can't see those slight tolerance differences, I can definitely see where rework comes in or grinding comes in, or, because I think if we talk about a basic welder, right, an automated welder, it's just following a path. Not very, not, there's not a lot of intelligence there. And when it's a car body, well, it's a big path, right? So you put a lot of stuff down, you got very big parts, not much to go wrong there. But on other products like the products you were talking about, the variation in the raw stocks and maybe slight differences in jigs or stands or just the people putting these things together could make the automatic system not as optimal as possible. And that's where your new system comes in, because you're giving it the intelligence and tell me if I'm right about this, you're giving it the vision and intelligence to be able to adapt on the fly.
Absolutely. Um, I mean, you nailed it. The fact that this is an art. I mean, this is let's say the alchemy of welding that the human welders have mastered over the last 100 years is how you actually deal with variations, how you have the motion, hand skills trained in your arms, and the eye and cognition to be actually react to those variations. That makes human welders so valuable today and for many decades to come. We need as many welders as we can get. But where automation can help is now enabling those robots to see and react using the AI, using the intelligence, as you mentioned, and the vision system to be able to see those variations in a very, I should say, I don't know if you're familiar with the welding environment, you have fumes coming in, you have the weld spatter, you have the heat close to the sensor, and to be able to withstand all of that and be able to produce the intelligence that's required by the AI to then command the robot to tell it what to do is really key in how we solve this problem.
Yeah, and the
Uh,
electrical side too has to be really robust because there's a lot going on electrically as well. Go ahead. I
Absolutely.
didn't mean to
Yeah.
interrupt. Go ahead. Back.
No, you nailed it. So, like, that's interesting, actually. Let's just segue into that for a sec. One of the challenges with any welding automation solution is the fact that you have hard current going on and you have servo motion at the same time. And depending on welding mode that you're in or the welding process itself, there are other nuances that happen. For example, in the TIG process, there's something called high frequency start. So you have a lot of electromagnetic interference from these systems, and that could actually impact the weld because weld in itself is a plasma that's directing the molten metal from one side, from the wire to the plate.
Yep.
So any kind of electromagnetic would naturally impact the weld quality too. And as I mentioned, things are very sensitive. You want that weld to be done absolutely right. So back to the discussion though, let's just put our control engineering hats on for a sec. And you think and compare a welding process to, say, autonomous driving. In autonomous driving, you're going from A to B. You can, the FSDs would know where A is, where B is, and the controller from input standpoint, you have the wheel, which you can go left or right, and the speed of that, and you have the brake and gas, and the speed of how fast you want to brake or how fast you want to put, how much faster you want to go on the gas pedal. But if you take that to the welding world, it's kind of multiplies by at least a factor of 3 or 4, because now there's a lot more things you have to care about. Yes, there is the A to B in 3 dimensions, so you have to go from XYZ here to XYZ over there. But you also have to make sure that you have the right weave amplitude, for example, which is a very important part of the weld process, the weld frequency, the dwells on each side, those are on the motion side of things. And you have all the weld parameters, which includes the voltage, the current or trim, the wire feed speed, the travel speed. All that becomes part of an integrated part of the problem, the multi-input, multi-output you're trying to solve, to be able to make sure that you're doing the weld right in spite of all those variations upstream that are coming your way.
And so let's talk about how you solve this. I mean, I mean, it sounds like originally you had a welding cobot, but now you're using AI. So let's dive deeper into that. What is the solution from your company that actually gives this intelligence to these robots? Hey guys, I just want to break in here quickly and thank Novarc for sponsoring this episode. If you do reach out to them, please let them know you heard about them on the Automation Podcast. It really helps us with the vendors when they know that you, the listeners, are interested in their products and they're hearing about them on the show. And so when you reach out to them, if you just let them know you're hearing from us, whether it's this episode or another episode, please let the vendors know. We really appreciate their sponsorships. It helps us keep this show going. We want to do 50 plus shows this year. So and you can help us with that by letting vendors know who you're interested in, who you reach out to, that you heard about them on the Automation Podcast. And with that, let's go ahead and jump right back into this week's episode.
So we start really understanding from the production floors of our customers what is the actual problem. And I mean, we talked about the problem itself, but like what it takes to solve it.
Yeah.
Because these industrial robots have been deployed, they're producing parts right now, and those parts have geometries, right? So when you were talking about retrofitting a cell with an OVI solution, which is a vision system, and the control panel and all that integration with the controller, you have to make sure that that solution works with that system that's already been deployed. So as a retrofit to these existing welding cells, we have considered how the vision system would be integrated with the robot, because it's, again, later on to the cell. So we want to make sure that it doesn't interfere with the robot motions. It doesn't interfere with the part geometry. So if the robot has been programmed in a way, for example, and now we're adding this vision system, how does it limit or the motions of the robot, and how that has to be reprogrammed maybe to some degree to make sure we always have the right view that we're looking for without interfering with the cell or the part. So that's one part of it. The other part, as we talked about, is ruggedization of the camera. Like, what is the environment? What's the duty cycle that these robots? And they're high. If you look at the high volume, low mix manufacturing plants, those are very much high duty cycle environments. And you have to the vision, the sensor has to be able to withstand the heat, the spatter, and everything that's going at it. On the other side of it, we're talking about the cabling and everything that goes to take that signal back to the compute. So that's in itself is a challenging challenge that we have taken on. And then you got, of course, the AI that runs on the edge. So we have high compute power deployed on the cell, probably like 1,000 times factor of magnitude stronger than anything that's close in that cell, because these are NVIDIA chipsets that can run deep neural nets on the edge and be able to translate that now to a real-time control signal that's transferred back to the robot controller to say, hey, I've seen this feature, and now you have to compensate for it by changing the motion or weld parameters in a specific way in real time. So this entire loop has to be closed, let's say, in less than 500 milliseconds, just to give you a rough idea. From seeing to reacting, and including the moments and how long it takes to actually the reaction time of the system, I should say, before it actually impacts the weld. So this closed loop system basically has to work within that cycle time, and the Novi solution that we've been working on it has been able to address the challenges with the part geometry, the fact that there needs to be space and the real estate on the end of the arm tool, the fact that it has to work with a ruggedized environment, it has to be ruggedized to withstand the environment, and the fact that it has to be able to integrate with these robot controllers to do what we needed to do, natively, that is. So I know I'm happy to say, like, we've been working on this interesting, but we showcased it actually for the first time as a prototype in 2022 at FabTech, and we've been on this journey of integrating more robot brands with it and launching it to the market.
So yeah, a couple of questions based on that. So real-time closed loop control. And I guess, and I'll ask this my first question. Are you monitoring just the physical parts that are being welded, or are you also looking at the actual weld that's being laid down?
Great question. Yeah, no, we're actually looking at the weld process itself. So the molten pool, we're looking at the joint and a very much a close-up of the welding scene. We're not looking at the entire part. We're looking at what's happening with the analog, I should say, weld process itself.
Okay. Now, the other thing too is that, of course, you make your own welding robots, so this would be a great add-on to that. But are you able to put the same system on other robots that maybe don't come out of your shop?
Absolutely. So that's the thing. So the 400,000 welding robots I mentioned, many of them are robots we have not manufactured. They're from the top brands like Fanuc or Yaskawa or ABB or UR or other brands. And we can actually retrofit this on their systems that are out there, which is a huge, again, value for our customers, because for the first time, they can address some of those rework challenges we talked about. And they're known, they're quantified to some degree, but they have not been able to find a way around them. So this is a very, I should say, efficient way of getting more out of the cell in terms of productivity, reducing the rework for a lot of manufacturing plants that are trying to get more out of their assets.
Yeah, I think if you're a vision expert, trying to implement a system like this on a robot, if you're not a welding expert, would be very difficult, very time consuming. But since your company is already has expertise in welding robots, I mean, that's your pedigree, right? That you figured out how to do this, make it robust, make it be able to fast enough, closed loop, use enough horsepower. That I could see that if somebody had one of your systems or somebody else's system, they're like, we just need more intelligence on this. There's just too much variability. It's causing us headaches. We're either putting down too big a weld, or we're having to grind things off, or we're having to do manual rework. That's when they would want to reach out to you and say, "Hey, we heard you guys have this smart system that can go on really almost any welding robot. Can you take a look at our system and see if you could recommend something to fix it?" Because at the end of the day, all of these systems have similarities in how you would course correct or adjust them as they're welding. So that's very interesting. Do you see this technology you've designed, right? It seems like broad applications in the welding industry. Do you see other industries where you could apply it, maybe outside of welding, or is this strictly just for welding?
Great question. So at this point, it's just strictly welding. I think that's one of our strengths and maybe one of our weaknesses, that we've been very much focused on solving this important problem.
Sure.
I think it's a valuable problem to be solved. It's a hard problem to be solved. So we've been putting all our efforts into it. Um, and Novarc is unique, as you mentioned, in able to solve this problem because we control all the four elements. We can custom build robots and manufacture them. We have so that's a robot pillar, and then we got the vision pillar where we can develop vision solutions. We have the AI and the data behind it, which is another part of it. We have been able to collect a lot of data from our customers that are using our robots, and we have been able to leverage that then to train the AI for the and the weld logic that's required to control these other types of brands of robots. And then we have the AI pillar. So be able to mix all those four in a solution that customers that can actually use on the floor practically is what Novar can bring to the table.
Yeah, I'm just thinking outside the box, that there's other applications very similar to robotic welding that this system could also work on. So that'll be interesting to see how this evolves in the years to come, where it's like, hey, this is very similar to a welder. Maybe we could use a solution there. Very interesting. Now, if somebody wanted to find out about this, let's say they have a system that they want you to look at. They say, hey, can you quote maybe or take a look at this and see if this is something your application would fit? Who would they contact? How would they reach out to you? How would they find out more about your company? What's your website?
Absolutely. I'm happy to share our website with you guys so I can share my screen. So this is the Novarc website. You can learn more about the Nov AI product offering and its adaptive welding capabilities on this page here, where we talk about how we solve the problems, how we combat the overwelding, the pre-scanning, the touch-up issues, and what are the system capabilities. And something we didn't touch on was also equally important was the fact that we can actually, for the first time, create that intelligence platform for the welding cells. One of the long-standing issues here is the fact that what happens in the welding cell, really nobody knows, and it's really hard to trace it. But by creating a video record of that weld with all the motion parameters uploaded to our cloud solution, NavHub, now the operations managers, actually the manufacturing engineers, can actually see what happened in that weld, and they can go back to it. So this really enables the manufacturing plants to get a lot more in terms of knowledge and intelligence on, like, what is the input quality from my vendors, what is the prep quality from my fit up station, what is the throughput for the shop, and from quality engineers that are managing those welding cells, what is the actual how well have we been strict limiting the cell to what in terms of current or voltage and weld parameters to the weld quality requirements that are required and specified for that weld. Are we within the voltage and current limits? Because at some point, if you're not, then you won't be able to sign off on the quality of the weld. So for the first time at a large scale, we can deploy a solution that customers can actually rely on from welding intelligence platform, knowing what's happening in the welding cells. So you're welcome to learn more about our product here. And I also would like to encourage everyone to join us and follow us on LinkedIn. We do have a persona called Jack Novarc, where we share the latest and greatest that we have when it comes to welding automation solutions and our welding cobots. So please follow us on LinkedIn.
I want to go back and ask about the system you had, the cloud system, I could see that would be very helpful for the data, right? The video, the
Yes.
data, all that stuff. Um, do you actually get to the point where you train your customers to be able to make minor adjustments as time goes on, or is that something you always do in-house?
So it depends on the type of adjustment. So sometimes our customers use the Nav Hub to be able to identify issues in the upstream processes. Sometimes they want to understand what's happening in the welding cell, and sometimes they want to use it for post-weld verification. So they can upload their weld quality reports there. They can track what has happened. They can trend
Nice.
it if they want to. So those are the kind of adjustments that customers can do to their operations based on the data we provide. But we also can make improvements to our AI, of course, by leveraging that data to train it, further train it on different joint geometries and different weld scenarios that could happen.
Now, it sounds like that connection to the cloud is optional. Is that correct?
Well, we do provide it as part of the product. So, and
Okay.
and the Nova has three different variations. There's a capture, control, and autonomy. We talked a lot about autonomy, but customers can start if they don't want to leverage AI right away in their production. We typically so far have been started with a capture or control, where they can actually mount a camera, they can monitor the weld pool, with the connection to NavHub, the cloud solution, they can actually collect all the videos of the weld and kind of run reports on them, and that's the starting point. And then Novia Autonomy is a later addition that comes. And we actually haven't launched it yet, so stay tuned for that launch this year.
Yeah. That's great. So a nice phased deployment, so they don't have to just do everything right away. They can start
Correct.
getting the intelligence and then go forward from there to control and whatnot. All
Absolutely.
right. Very interesting. Was there anything else you wanted to cover? Those were all the questions I had. Was there anything else you wanted to cover while we have you today?
Yeah, absolutely. I think we are in the as Economist magazine calls it, the Chat GPT moment of manufacturing, where for the first time the AI can really make a practical improvement on production floors. And we're proud that we can make a small contribution to that with our Novi AI solution. We can leverage the power of AI to solve an important problem for the manufacturing and the welding automation world. So we are very passionate about this problem. This is a challenging problem, to say the least, but we would welcome anybody who wants to help us solving this problem. To all the control engineers, well, hopefully this was an inspiring podcast, and stay tuned for more from Novarc Camp.
Well, Soroush, I want to thank you very much for coming on the show. This is just such interesting stuff. I hope to be able to catch you at a trade show sometime to actually see it in action. But very, very interesting. And of course, to the audience, there'll be links in the description if you want to find out more about the company and maybe links to videos or their solutions. But with that, Soroush, I want to thank you for coming on the show. Really appreciate it.
Thank you so much, Shawn, for having me. Appreciate it.
Well, I hope you guys enjoyed that episode. I want to thank Soroush for coming on the show and bringing us up to speed on AI-powered autonomous welding robots, as well as I want to thank Novarc for sponsoring this episode. I also want to thank you for tuning back in this week. Feel free to leave comments anywhere the show is. I think all the platforms notify me when somebody leaves a comment. And if you have a chance, please leave us a 5-star review on the podcasting platforms. You know, we get thumbs up on YouTube and likes over at the Automation blog. But when we're talking about the audio destinations, it's very helpful when you guys give the show a 5-star review. That way, if somebody's looking for automation shows, they see that our audience really likes what we do. So with that said, I do want to wish you all good health and happiness. And until next time, my friends, peace.